All right, guys, we're back with our perspectives of IPv4 subnetting, right? And so again, I know this is a hard skill to grasp, and it takes a lot of practice. So again, I showed you guys how to go ahead and do that conversion via the technique that it's called positional notation, right? By of course, marking out your bit location. So 1, 2, 4, 8, 16, 32, 64, 128, right? You guys know all of this, right? So what we're going to do, right? And I'm going to show you guys from a Cisco perspective how this looks if we try to configure, right? We try to configure a subnet, right? That maybe is overlaying another subnet, and where variable length subnet mask comes in, right? And how we can benefit from it. Okay, so I have this network, right? I have one switch on the left, one switch on the right, right? And the plans, right? Us being the design engineers, the plan for it is so that whenever R1 connects to other routers, it can send traffic that's destined for 10.10.199.0/24, right? It can send it to us, then we can send it anywhere, right? But let's go ahead, right? Let's go ahead and try to go ahead and configure it on both interfaces. First, we're going to do it off of gigabit 0/1, right? Because that's what switch 1 is plugged off of. And we're going to do it on gigabit 0/2. Okay. First, let's go ahead and confirm that. So let's do a show IP interface brief. All right. So we see everything's down, right? And so let's go ahead and enable this, right? And by default, guys, just a reminder, right? A router, a Cisco router, that interface will always be administratively shut down as soon as you open up the box. You will have to go in and configure it. Versus a switch, all the ports are open, ready to go, and they're all in VLAN 1. Okay? So let's go ahead and configure this. All right? So we're not going to add an IP address now. We're going to say no shut, right? Went ahead and came up. And let's do the same for gigabit 0/2. And we're going to do no shut. All right, so it went ahead and came up. So let's do a show IP interface brief. All right, so we see these interfaces. Let's do a show interface brief. Whoop. And this is old OS, so it may not have that command. That's right, we are in global config mode. Let's do a show interfaces. That should have. It doesn't have brief. That's fine. Let's go ahead and do a show interface gigabit 0/1. Let's go ahead and check that. All right, so layer 1 is up, right? We go ahead and configure that. The line protocol is down. Let's go ahead and check that before we do anything. All right. All right, let's confirm what's plugged into what. That down. All right, perfect. All right, so let's go ahead and check what this is plugged into. All right. Let's take a look at all of this. Let's take a look at this switch. There we go. All right, so the switch is booting up, and it may just be the power was off. Good old layer 1. Let's go ahead. And if you guys, of course, this is one of the first times I'm using packet traces. It's a very intuitive tool. I suggest you guys to use it if you're on the go. Maybe you don't have access to real equipment. This will give you as much as you need as far as in prep for the CCNA. Okay. All right, so we got that set up. We're good to go. So it looks like it was just a layer 1 issue. All right. Now let's pull back up R1. So if we go ahead and we pull up R1, Let me go ahead and close this and close that. Perfect. All right. Perfect. Right. So line protocol is up and up. Right. So layer 1, layer 2 is good to go. Right. Let's go ahead and just verify. Perfect. All right. So it's good to go. All right. So let's go ahead and do some configuration. All right. So let's do a interface gig 1/0, and let's do a IP address, and we're going to do 10.10.199, and we'll do a 1 on that side. And let's do 255.255.255.0. And let's do a no shot. Right? No problem, right? It's in a /24 in regards to a CIDR notation, right? So it has 24, right, subnet bits that are assigned to the number 1. That means that they're on, and 8 bits, right, in the entire subnet mask that are off, right, and they are reserved for hosts, right? And the amount of hosts that they can fit is 254 hosts in total, okay? So I'm going to go ahead and configure, right, the other interface for 10.10.189.2. Let's see if that works. It does not, right? So you guys heard me say it time and time and time and again that each interface on a router is a broadcast domain from a layer 3 standpoint, right? So we have a /24, right? So since we assigned, right, a /24 for 10.10.199, right, for that, and I'm just talking about the network portion. So since that network is assigned to gigabit 0/1, we can't assign it to another network because that's already assigned to something else, right? That covers the entire subnet, right? That entire /24, that entire 255.255.255.0, right? But what happens if we subnet even further? We could potentially make this work, right? Let me show you how we can go ahead and knock this out, right? So let's say switch 1 is for sales, switch 2 is for engineering, right? And each of them have, let's say, 100 people, right, in each environment, right? So we remember our rule, right? We can do 2, right, to the power of however many bits, right? So let's say, and again, what I like to do, of course, if I have the resources available, go ahead and let the calculator do the work, right? So I'm going to do 2 to the power of 5, right? Because my goal is 100, right? Minus 2, right? Because we need to take out for the broadcast and network address. That's still not enough, right? Because I want to go ahead and subnet, right? Subdivide, right? This /24, right? 30 is not enough. I need enough for 100, right? So let's go ahead and do it again. Let's do 2, right? I did 5 last time. Let's bump it up a little bit. Let's do 7, right? And let's minus 2. That's enough, right? So that is, right? That is 126. So we should have enough, right? And so, right? 128, right? That is the last bit, right? If we're doing our count, we got 1, 2, 4, 8, 16, 32, 64, 128, right? This would make this a /25, okay? A /25 network, right? So to make this work, right, we would have to first go ahead and reprogram the first broadcast domain in the /24 subnet, right? And in this case, right, /25 is going to be the subnet, right? The supernet, okay? The overarching network, okay, is going to be that /24, aka the supernet, right? And of course, I'm giving you guys Easter eggs for what's to come. All right, so let's go ahead and reconfigure the supernet that's configured on interface gig 0/1 and configure it for a subnet of /25. All right, so let's go ahead and let's exit, right, interface gigabit 0/2. All right, let's go back there and let's say no IP address. Okay, all right, we took it off, right? And let's go ahead and verify. Let's do show run interface gig 0/1. It won't let me do that. This is older code. So let's go ahead take the time, right? Because we're engineers, to go ahead and confirm that. And let's do a show IP interface brief. All right, so there's no IP address because of course we would have seen it right here, assigned to gigabit 0/1 right now. So let's go back and let's assign the subnet, right? The subnet of /24, which is going to be, we're making it a /25, right? And it's going to provide 126 addresses to each subnet, right? Right? Each /25 from the supernet of /24, right? So let's go ahead and do that. Basically 0/1, right? And we're still going to give it, right? A 10.10.99.1, right? But what's going to change, because again, we need to say from a layer 3 perspective, what identifies the network portion and what identifies the host portion, right? All right. And we said, right, it's going to be a /25. So that means it's going to be a 128. Okay. All right. And it's already been shut, so we don't need to do that, right? And of course, right, it starts at 0, right? So every subnet, right? Every subnet always starts at 0. Every network starts at 0, right? If we start at the top of it, right? And it goes all the way to the end of it, right? For the entire range, right? So it goes from 0 all the way to 127. Okay. The next network is going to start at 128, right? So let's go ahead and do interface, right? We're going to program the other network, right? So we're going to do an interface gig 0/2. We're going to do IPADR. Then we're going to do a 10.10.199. And we're going to start again because we have to start in the new subnet, right? The usable host, right? So 128 is the network address, right? 129 will be the next available, right? And we're still here, right? No overlap error, okay? We'll do a no shut, exit, right? And let's take a look at this. Let's do a show IP interface brief. Awesome, right? So we subnetted the /24 into a /25, right? But how can that help, right? Let's go ahead and pull up another route, right? Let's go ahead and grab one. Let's grab another 211, right? And you guys will see the benefits here of why this is so important, right? So let's go ahead and grab this. Yep. Let's go ahead and power it up. Let's power it up now. It's fine. And, right. Let's let it power up. Let's go ahead and give it 6.4.2.0/24. Let's do that. All right. Let's move this bad boy around. All right. Make them look pretty. All right. There we go. And let's move this so you guys can see it. And let's move that. There you go. Excellent. All right. So now let's pull up R2. Excellent. All right. So we're in R2. And let's configure. All right. Let's configure an IP address. And let's, and I'm going to show you guys. And of course, you guys can take notes of this, but you're going to see how us doing subnetting helps with routing. It helps with summary routes, et cetera, et cetera. So let's do R2, right? And I'm going to do interface gig, right? I'm going to do 0/, let's do 0, right? IP address 6.4.2.2. Okay. We're going to do no shut, right? We got layer 1 up. Okay. And we're going to pull up R1. We're going to do the same thing, right? We're going to assign an interface in that same subnet. Okay. Interface gig 0/0 because we see that's free. 6.4.2.1. Excellent. No shut. Excellent, right? All right. Save that config. Save that config. All right, let's take care of layer 1. All right. And let's get them connected. Perfect. All right, so we got them connected, right? So us having them connected, I should have layer 3 reachability, right? Just on the link, right? So let's go ahead and try. Let's go to R2 and let's try to ping, right? So if I do a ping 6.4.2.1, right? Right? I get success, right? Let me try to ping, right? 10.10.189.1, right? Of course, we're going to go ahead and get failures, right? Because we don't have routes for it, right? Let me try to go ahead and ping 199, right? 129, I apologize, right? And that's the other subnet, right? The other /29, that's other /25 that's assigned to the other interface, right? All right. So to go, of course, fix this, right? All I have to do is go ahead and assign a route. So I do IP route 10.10.189.0 O.O.O.O. Give me 1 second. Let me, yes. So this is 55, 55, 55, and we are a /25, so it's going to be 128, right? And that next hop is going to be 6.4.2.1. Okay, right? And we're going to do the same thing, right? It's going to be a 128, right? Because whenever you're setting up a route, right, and it's not for a direct host, it's for a subnet, you put the network address, okay? You're always going to put the network address, okay? So if I go ahead, try to ping now, I get success, right? Right? They all work, right? But I had to put the specific, right? The specific subnets, right? That did work, right? But let me show you how variable length subnet mask helps, both sides, right? The source and the destination, right? The internet is not going to know about every network that would have you. They're going to maybe subdivide and know about your subnet, right? Maybe about your supernet, right? The overarching network, right? That covers some of the subdivided networks, okay? So let's take away what we added, the routes, and let's add this. Let's go ahead and add the supernet, right? 10.10.189.4.2.1. Okay. First things first, let's look at the routing table. Let's examine that. Right. So we know how to get to, right, 6.4, right, 2.0, right, because we're connected, right? We have an interface that's assigned with the 6.4.2 network, right? But what about the 10.10.199 network, right? We have the /24 configured, right, for that network, right? Does that mean we'll still be able to reach the subdivided networks from /24? Let's try it. All right, I'm able to ping .1. Let me see if I'm able to ping a 129. Right? So what does this tell us, right? Is that internally, right? And this is where subnetting comes in, because we can go ahead and, save IP addresses, right? You guys saw that I went ahead and said, the sales department, which is under switch 1, they don't need 254 addresses in their network, right? We need to save some maybe for engineering, maybe for the business or what have you, right? So they only needed 100 in sales. So we gave them a /25, which allots them for 126 usable IP addresses, right? Doing subnet math, okay? And so we just gave the rest, right, to the other interface. It is possible to do so. The other lesson we learned here, right, is that we cannot have conflicting, right, conflicting subnets, right, on different interfaces on a router. Going to have to remember that, okay, for the exam, right? So if I have this, but it's a /24, I won't be able to configure this on another interface. But if I have this and it's a subdivided network within the overarching network, right? /24. If I subdivide it to a /25, it can fit, right? And how will that help with routing, right? From a routing standpoint, right? R2 just knows, hey, 10.10.189.0/24 and all the addresses and the host bits that exist within a /24. I just got to go ahead and send it to 6.4.2.1. That subnet lives over there, right? And R1 is going to say, that's where I send it. That's it. Okay. But you have to properly and slowly do your math, do your calculations or what have you to go ahead and properly plan this. Now for the exam, because this is what this is for, you will need to write out, just like how we did in that last fun day. And of course, watch that video again if you didn't see it, if you weren't in that session actively. But you're going to have to write out your subnet map, okay? You have to write that out because you will be quizzed on what a subnet is, what it means, and how to actually convert binary to decimal and decimal to binary. Okay? Guys, I hope this was helpful, and I'll see you guys tomorrow.